All right, so we're going to continue on here now with quadratics. We've talked a lot about this stuff before. Actually, in 1.7, we discussed this, but there's a few things that are new here. So, what does a quadratic function look like? Well, we know what a graph looks like. The graph looks like um, just a parabola. So, if you look at these right here, we talked about this formula right here last chapter. Okay, so this says describe how to transform the graph of f of x equals x squared into the graph of the given function. Sketch its graph by hand. I really don't care much about sketching it by hand because we're going to do this all on the Chromebook. But you should all be able to tell me what this negative 1/2 does to the graph. This negative 1/2 right here, the negative is going to flip it about the x-axis, okay? And the 1/2 is going to be a vertical shrink by a factor of 1/2, right? When it's less than 1, it's a vertical shrink, or it kind of widens it. And if it's a greater than 1, then we call it a vertical stretch. Okay. What is this plus 3 out here? This is my K. This is going to shift up 3 units. So if I were to draw a rough sketch of this, okay, I know that it's not going to go right or left. It's going to go up 3, and then it's going to have a vertical shrink, which means it kind of gets wider and it flips about the x-axis. So if I were to graph that into Desmos, it's going to look something like that. Same thing here. There's no flip, but this has a vertical stretch by a, which is 3, by a factor of 3. Okay, it's going to move. Remember, this is the opposite inside, so it's going to move left 2, and it's going to move down 1. So if I were to draw a rough sketch of this, it's going to go left 2, down 1. There would be my vertex, and it's going to have a vertical, so it's going to go kind of a little bit skinnier, right? It's a little bit skinnier when it looks like this. Sorry, right on this looks like a V, but it should be a U. Okay, so there's my vertex at that ordered pair. So those are things that we should be able to do. Again, I told you this book really likes to hear itself talk. I'm going to go over both of these, but this is really talking about the axis of symmetry, or axis for short, is always the x value of the vertex. So what is the vertex? The vertex is the highest or lowest point. So we're going to really study how the vertex and how to find the vertex here on these next 2 slides. So I have already discussed this form with you right here. Vertex form. I discussed in great detail what A does to the graph, what X does to the graph. I'm sorry, what H does to the graph and what K does to the graph. What I didn't really talk about is the vertex, which is always the ordered pair HK. Okay. Well, where does HK come from? Look at this. Remember, this is always the opposite. Just like when we shift left or right, and then the K is always the same. And then the axis of symmetry, which is the line that kind of cuts the parabola in half, is always x equals h. So I know the homework asks you to find the vertex and find the axis. I'm going to kind of give you an example here that we just talked about and show you how simple this is to find all these things. So if I ask you for the vertex is this number right here, but it's the opposite. So the vertex would be 3, and it's the same as this num, comma 4. And then the axis of symmetry, or short, is axis is x equals 3. It's always this value right here. That's when it's in uh, vertex form. The other form is standard form. If I have standard form, okay, then we are going to find the vertex by taking the opposite of B over 2 times A. And then I'm going to find the Y value by plug in the X value to get the Y value. So that, plug it back into the original equation. So if I gave you Y equals a 2x squared plus 4x minus 3, to find the vertex, I would do the opposite of B, which is negative 4, over 2 times A, which is 2. So again, take a look at your signs. Make sure you pay attention to that. That's negative 4 over 4, which is negative 1. This is the X value. How do I get the Y value? I'm going to plug it back into the original problem. So 2 times negative 1 squared plus 4 times negative 1 minus 3 would be 2 times 1 minus 4 minus 3, 2 minus 4 minus 3, which is negative 2 minus 3, which is negative 5. So I've had the order pair negative 1, negative 5. And then the axis of symmetry, it's the same exact thing, is just x equals this value right here. So it'd be, sorry, I'm running out of room. X equals negative b over 2 times a. Well, we already found that value. It's just this one right here. So the axis here would be x equals negative 1. It's always the x value of the vertex, okay? So there's one little problem here that I want to talk about. I might do a couple of examples of this, but this is called completing the square. I'm going to try to explain this in a step-by-step process and then show you the actual math over here on the left, okay? So the first thing that I need to do, step one, is I need to get ax squared plus bx on one side, okay? On one side. So I've got this problem right here, 3x squared plus 12x plus 11. I need to get ax squared plus bx on one side. So what needs to move here? I need to move this 11. Notice I'm ignoring the f of x. I don't need that in the problem. So I'm going to subtract 11 and move it to the other side, right? This is equal to 0, so I've got 3x squared plus 12x equals negative 11. The second thing I'm going to do is factor out a. Whatever this number is, it needs to factor out. So I'm going to factor out a. So this right here is step 1. Here's the process of step 2. I'm going to factor out a 3. It's going to leave me with an x squared, and then watch how I write this. Again, where'd the 4x come from? I'm taking this and dividing it by 3. I'm going to put a plus a blank here, and is equal to, and I'm going to put is equal to negative 11 plus a blank here. I'm going to put something in here that is called completing the square, okay? So why did I put a blank here and here? Because in algebra, we have to keep things balanced. This side has to equal this side. So whatever I add here has to go here, okay? So the third thing I'm going to do is I'm going to take half of b and square it. Not b from the original problem, b from what we just have. So half of 4. So this right here is half of 4, which is 2, and square it, which is 4. Well, I put a 4 here, but don't forget I factored out this 3. If I were to distribute this 3 to all of these numbers, what is 3 times 4? It's 12. So if I have to take out an a, which I did here, I have to make sure that I distribute it to show that this is really the number 12, and that's what I'm adding over here. If there is no factoring, if you don't do anything in step 2, then this number will be the same as that. But this is really the number 12 because I have this 3 out in front. Now, the whole reason that I did this is because I can now rewrite this problem right here as x plus 2 squared. So step 4 is to rewrite the quadratic as a perfect square. It will always be a perfect square. Okay. And then what do I have on the other side? Negative 11 plus 12 is a positive 1. Okay. And then now put in vertex form. And I've got subtract 1, subtract 1. This is in parentheses, so I can't combine that. I've got f of x equals 3 times x plus 2 minus 1. Don't forget to square it. So this is asking us to do that. Then I could graph this, and if I graphed both of these in Desmos, I would have the same exact graph. Okay, so I've got 3x squared. Let me just get all this out of here. What was it? 3x squared plus 12x or plus 11x, plus 12x plus 11 plus 12x plus 11. And then when I did that other graph, I'm going to go back to the home so you can see that the graph is right there. I've had a 3 parentheses. Inside it was an x plus 2. squared, and it was a plus, or I'm sorry, a minus 1. And you can see that these graphs are right on top of each other. It's the same exact graph, okay? So we're just taking the function and rewriting it. Let's take a look at one more of those examples. I want to, not what I wanted. Here we go. I want this one right here. Okay. So let's go ahead and take a look at one more of these. Um, Hold on a second. Let me find it in the book. And again, this is called the process of completing the square. I want a specific example here from the book so I can talk about something. Here it is. So I've got negative 3x squared plus 6x minus 5. Okay, so what's the first thing that I need to do? And again, this problem will look like this. We just ignore that for now. I'm going to get these two terms by themselves. So I'm going to move this 5 to the other side. So I've got a negative 3x squared plus 6x, and this is going to equal, I'm going to add this to the other side, right? So this is going to equal a 5. I'm going to factor out a. If a is negative, I have to factor that out. So I'm going to factor out a negative 3. It's going to leave me with x squared. What happens when I factor this by negative 3? The sign changes. Okay. So plus minus 2x plus a blank equals 5 plus a blank. So whatever I put here, I'm also going to put here, but don't forget I'm multiplying that by negative 3. So what's half of negative 2? It's negative 1. Negative 1 squared is equal to 1. This will always be a plus because I'm squaring it. So what number did I really put here? I put a negative 3, right? I'm going to take this number and distribute it. If there is no a here, then I don't have to worry about distributing it. So I'm going to rewrite this as negative 3 times x. I take half of this number. That's what I always get to factor that. So half of it, square it, and that's equal to a positive 2. I'm going to move the 2 over. I got negative 3 times x minus 1 squared minus 2 is equal to, I'm going to put equal to f of x. F of x. So this is the process of completing the square. Follow those steps that I gave on the last slide. You should be fine. I'm going to show you one more real quick example. If I had like x squared plus 6x minus 3, I would get this x squared plus 6x, and I would move this to the other side. Well, there's nothing to factor here, right? There's nothing in front of here, so I would just go half of b. I'm going to put a plus blank equals negative 3 plus blank. Whatever I put here now, because there's no a, I'm going to put here. So half of 6 is 3. 3 squared is 9. I add 9 here. I add 9 here. So I'm going to have x plus, to factor this, you always take half of that number. Okay, equals a 6. I'm going to move the 6 to the other side, and I get x plus 3 squared minus 6 is equal to f of x. Just wanted to show you one where I didn't factor it. So, guys, again, I apologize for missing this Tuesday. Next week's my son's last therapy, so I shouldn't be missing too many more of these. But please attempt the homework. I know the notes are kind of lengthy, but you can pause it and write down what you need to. Have a great Tuesday. I'll see you guys all on Thursday.